Do you want to introduce me or shall I introduce myself?
Oh yeah, sorry.
Jason, why don't you go ahead?
Yeah, you could just introduce yourself. Yeah.
Okay. Hi, I'm Matt Howard. I'm a smart contracts engineer for Chia Networks. And today I'm going to be talking about decentralized identity in Chia. So the first question is, what is decentralized identity? And this ties into the question of what is identity? And online, identity at the moment takes the form of usernames, of email addresses, and Facebook OAuth tokens. And it's more or less a way of identifying people. And you can then use that for authentication and to form groups. And decentralized identity is this new experimental standard that's been defined by W3C and is being researched actively by the Identity Foundation, DIF. And in practice, there are a number of different implementations of this standard where people are working out what the best approaches are. And there's a quote here from the W3C spec that it is a globally unique, persistent identifier that does not require a centralized registration authority because it is generated and or registered cryptographically. But the disclaimer I want to say is that this is a developing technology and there's different strands and ideas. And even for me and Chia, this is developing tech. So if you watch this recording in the future, subject to change. So here is another quote that I thought summed it up pretty well. You can screenshot, pause the video if you read this. There's a link at the bottom. I'll send the PowerPoint through so you can look at the slides as well. So what does this actually mean? Effectively, what you get is URLs for people. And it takes the form of this. DID, that's the equivalent of like the protocol description. So for a website, this would be http://. But because there's multiple implementations, it needs an extra section to specify which implementation you're looking at. So for me, I'll be talking about DID Chia. And then you have the actual address, which is an alphanumeric string that's dependent on the implementation. And then this can be resolved to a single DID subject. The DID subject can be a person, a group, an organization, physical thing, digital thing, whatever, it doesn't matter. But it resolves to uniquely one identity. And here you can see that multiple people have implemented this, sometimes even on the same blockchain. And in particular, you'll notice that this one is deprecated, again, emphasizing that this is all in development, lots of experimental ideas in this space. So there's some concept of a URL that connects to an identity and that can be used to authorize. So before we go on, I'll talk a little bit about Chia as well. Chia is a new cryptocurrency that was founded by Bram Cohen. He's the man who invented BitTorrent. So the copy of Ableton you have on your laptop is thanks to him. There were his thoughts on the matter were that there were several inefficiencies in Bitcoin that could be fixed. The main one being the horrific use of proof of work, which is bad for the environment and centralization. There's much literature on this. And also that Bitcoin script is not very good. It's very complicated and verbose, but actually difficult to wrangle anything useful out of it. And it uses the stack memory model, which is, again, not great. But he recognized that the two good things that Bitcoin does is the UTXO model for coins, and it has true Nakamoto consensus. Now, the consensus stuff's not really what I'm talking about today. I'm here to talk about smart contracts. So the smart contracts, I I'm assuming that the people here have some familiarity with smart contracts in Ethereum. And the critical difference between Chia's ideas for smart contracts and Ethereum's is that in Ethereum, a smart contract is an object that you interact with. But in Chia, a smart contract exists inside of the coin. The smart contract is a program that is a fundamental part of the coin that controls its behavior. So the strap line we have is smart coins, not smart contracts. We use a Lisp-based language. So it's a functional language, which gets rid of the stack memory problems. And we also, we have much less information when calculating a coin's ID. So if you're familiar with what SegWit is, segregated witness in Bitcoin, it's like that, but more. We pull out as much as possible to have the minimum viable, sensible coin ID, which we've worked out to be the parent ID, the puzzle hash, and the amount. And that's what makes up a coin's ID. And that puzzle hash is the commitment to a puzzle, which is the contract that exists inside of the coin. And then when you spend it, you reveal the puzzle's source, and then it runs the code as part of the spend. So I just wanted to throw in a quick guide to ChiaLisp because I wasn't sure what the familiarity with Lisp would be like in this group. So there's a link there if you want to play with ChiaLisp. We've got the CLVM tools. That's CLVM is the ChiaLisp virtual machine, and that can run ChiaLisp. And in ChiaLisp, you've got atoms and lists. An atom is any literal value, integers, hex values, strings, doesn't matter, it's all the same. And then you have lists, which contain 0 or more atoms or lists inside of them. And then everything is built up out of that. Programs are lists where the first item in the list is an operator, and then it's just Polish notation or prefix notation. So instead of saying 10 plus 5 equals 15, you would say plus 10, 5 equals 15. And then we also have the solution, which is when you spend it, you pass in some information. This isn't so important because I don't go too much into code, but that's how Lisp looks. That's how ChiaLisp looks. So how does decentralized identity work in Chia? What's really nifty, and the main point of this talk, is that by putting the puzzle inside of the coin, it enables some really cool functionality. So we can do it where a coin is the identity, where you put a puzzle inside of a coin that ensures that it follows the DID rules. So this includes, you don't want it to be duplicable. You don't want anyone to be able to steal it or recreate it. And you want it to be able to send unique messages for authentication saying that my ID, Matt Howard, authenticate on the blockchain for the world to see whatever. I can authenticate anything I like through these messages. And if you have those two, then you can expand it to do anything you like, really. That's the meat and taters of DID. So what can this be used for? And this is what we are currently using it for, is identity-based recovery. So this is the case that you have your money and you can put it into a vault. And you have the keys to the vault and you can spend your money at any time. But if you lose those keys, you have trusted identities that can verify that you are who you say you are and allow you to access that money if you coordinate it. So I don't know if any of you have ever lost it or had to recover a Facebook account. They do something basically exactly like this, where they say, you need to get 3 friends and you need to have those friends attest that you are actually trying to recover your account and you're not a hacker or a bad person. So this is like that, but with money, or like with identity. So the flow of this generally is like this. You're a wallet with coins, and you can turn one of those coins into an identity. And then that identity will have some value inside of it, but fundamentally you're using it as an ID. And until you cash out, that's an ID that also just happens to have money in it. And the unique ID, so if you remember the DID Chia code, this comes from the ID of the Genesis coin in our implementation. And what's neat is that means that once you have that ID, you can trace the history. So anytime something happens with a digital ID, or if you just have that URL link to an identity, you can trace it and find the most recent version, see all the information related to that identity by just following the blockchain updates. So here's an example where the coin sends out a message and creates a new version, and then perhaps it updates its recovery information. As I said, that set of friends that allow you to recover. This is done basically by having two parts of the puzzle inside. You have the core, which will make sure that the identity related rules are enforced. You know, it asserts rules about what you can and can't do as outputs. But other than that, it seeds way to the inner puzzle, which is this instance specific, coin specific information. So that's where you'd keep your recovery information, your public key information for like what can spend this coin generally. And those two things are what constitutes the puzzle. And you can build up, you know, identity relationships of people who can recover you, and so on. Here is a diagram showing that. So why is this implementation special compared to the other implementations I was showing? Well, the other implementations I was showing are based around public keys. One question that you might have had when I was showing that definition about cryptographic identity is you might have thought, well, isn't that just what keys are? Well, yes, you can build decentralized identity around keys. But the problem is, if you lose your keys or your keys get stolen and you do a recovery, you're not regenerating the literal exact same keys. You're migrating that information to new key information, which means that your ID, as far as other people are concerned, changes. What's great about doing it with coins is that if you recover your coin that holds your ID, then you still look the same to everybody else. So again, I'd say this is similar to Facebook, where you don't need to make a new account, but you get all your friends. You get the same account, but your password changes. And the other thing that's cool about this particular one is it's based around decentralization. The coins are the contracts, and it's native to the blockchain. The Ethereum smart contracts, they are these wells of centralization on Ethereum. With the smart contracts on Ethereum, anytime there's a change of state, it's communication back to the monolith and back, and that is it's less decentralized. If you want to update it, then the smart contract has to go through the whole rigmarole. Everyone needs to check in with the contract. Whereas here, the coins are free to be their own individual instances. It is more decentralized. And from that, the question, where does the research go from here? So in Chia, we're looking to build smart transactions that can interact with identities. You can, because the identities are native to the ChiaLisp language, you can then build other things that interact with them. I can send money through that is only approved, that the transaction is only valid if it is approved by a known identity, for example. We can build groups and authentication. So you could imagine a university group, and they authorize the DIDs of its students, and then they can do on-blockchain activity that only people who are authenticated inside of that group are allowed to participate in. And the final place that we want to take this is contact methods. At the moment, most DID research is through the lens of authentication. But could we push it further so that you can contact an ID? If you have that URL, you can have some way of contacting that person. Could we make it so that there is arbitrary readable information on a coin, that so when people follow the DID URL, they can see some publicly presented information? And that's sort of where we're taking it. And that is it for the presentation. I know I kept it kind of high level. I can go into more technical details if people are interested in that, but I guess the floor is open for questions.
Yeah, I have a question. What kind of research have you done currently on how would you contact a DID? You were talking about URLs being embedded in the ID, and I'm wondering how that would be implemented.
So this is something that we're thinking about and having conversations about, but in terms of code written, not very much. It's something that we're interested in, but most research around DID at the moment is through the lens of authentication, and contacting is sort of a different way of thinking about it. We're trying to solve that problem of how to get both, but authentication is the main priority of it through the specification of the W3C.
So I'm pretty interested in this idea of the DID being in the coin, so that then you can update. You know, you can recover. Well, you call it recover, but it's basically reissuing keys, issuing new keys for an account that's been lost. How would this affect like the blockchain in terms of like bootstrapping from Genesis versus like having checkpoints or something? Would that affect it at all, or would that make? I mean,
it's what's great is that it's completely consistent. This is all happening just through the smart contracts. This is what is so cool about it. You don't need to mess with the chain. So you remember that diagram? I'll share my screen again. I had that diagram about the construction of it. So the inner puzz, what you're changing is the inner puzzle. What you're saying is, okay, my owner has new keys now, but the identity, which is wrapped in the core, remains the same. It just, you transfer ownership, and that's just a spend. That's a normal spend. And that on the blockchain, it just looks like a spend of that coin, but it retains its special properties. The public key, private key, the key pairs, those are different, but it's not doing anything like rewinds, no weird stuff like that. It's a totally normal spend.
I was actually kind of wondering if it could like allow for pruning of the blockchain, like if there ever was a case where it got too big, too much information, like because you have some of these components built in. I don't know.
Sorry,
I'm not sure if I know where I'm going with this, but
so these are just normal transactions. It's not like they. Am I disconnected? Can you guys hear me?
I hear you.
Oh, okay.
I hear you. It's got a little choppy.
Yeah, it has got a bit choppy. Oh, the internet in this place isn't the best. Oh dear. But no, these are just normal transactions, and it's not going to use up like it's not going to cause like a CryptoKitties situation if that's what your fear is. All right, I think the internet stabilized a little now.
What issue are you referring to for the CryptoKitties?
Well, Adam's question was about like congestion, right? Or actually, I'm not quite sure.
Sorry, I was actually kind of wondering, like, if the coins have this much information, like, what could that possibly do something even for, I don't know, something like pruning the blockchain, where if the blockchain is starting to get too much information on it, you wanted to say, okay, we don't need everyone to have all the blocks to come from Genesis type of deal, and have either checkpoints or pruning or something like that.
Oh, I don't think Chia has any plans to do like folding the chain, or it's always going to start from Genesis. So you are going to need, if you're interested in this information, to, you know, look through the blockchain. But I think in our implementation, we are planning something to do with the light clients that makes this easier for people to get at on a skim, but that's a little bit beyond my remit. Does that answer your question?
I think so, yeah.
Mm-hmm.
I have a question on you said that the Chia smart contracts are much less restrictive and there's no stacked memory. I was wondering if you could elaborate some more on that.
Okay, so it's stack memory operations in Bitcoin. It's based on a stack, right? You push information and pop information off the stack. But with functional languages, it's all based around eval. So you don't. There's no state to store. There's no memory like that. It's not a stack-based language. I don't know how familiar you guys are with Lisp, but
I see it. So it's because Lisp is more functional.
yeah, it's a functional language, which means that there is no stored memory. There's no stack memory.
Right. Okay. Of your current research, of the current research agenda that you have, what are you most interested in for the future?
With regards to DID, or
yeah, in regards to DID.
Groups offers a lot of opportunities. If you have authenticated in groups and some way of having that very neatly, then this does allow for really cool things. Because the idea of groups is quite powerful. You can think of it in terms of, the example I gave was a university, but you could think about it in terms of like legal rights. Like, these people are authorized to do this, and that can be enforced by the blockchain. You can do it as a nation. Like, for example, if the UK government wanted to hand out crypto pounds, they would want to make sure it was only going to British citizens, and they could do a British citizens group of identities, stuff like that. I think groups has a lot of potential.
Those are all my questions. I don't know if anybody else has any questions.
I guess I can plug the Chia Keybase. So if anyone has any questions in the future, then there's basically always someone online because of time zones. So if you can you pass on the link to that to your mailing list?
Yeah, I can do that.
And
Online.
if that's all the questions, that was my presentation on the matter. I think if people are interested, then they're welcome to play with the smart contracts and the ChiaLisp language. Personally, I think this stuff is really cool, and I was an Ethereum developer before I was working on Chia, and hands down, it's much better this way. Though there is a little bit of a learning curve because it's a different way of thinking about it. But if everyone's satisfied and I've answered everyone's questions,
I have one question. What was the most difficult part of transitioning, besides from the language, in going from Ethereum smart contract development to Lisp smart contract development?
It was due to the paradigm shift. In Ethereum, you can store state. Really, I used to program like Java and Python, and going from that to Solidity, it makes a lot of sense. And I think that's why part of the reason that Ethereum is so popular is that it's sort of easy. Solidity is kind of familiar to anybody who's done programming like that before. But there isn't stored state in Chia, which is a feature, and that's good. But thinking about it through the functional language perspective, it is different. And those ChiaLisp examples I gave earlier, those were simple examples. It can get pretty complex, but it's fun. I don't know. It's the kind of programming that I enjoy.
Did you do any of that programming before?
Any functional programming?
Yeah.
Not really. No. I had done courses on it at my university, but that I was coming at it as a Solidity programmer. That was my background, and I kind of joined the smart contracts team, and I worked on colored coins before I did DID, and colored coins are now live. You can go and play with them, and now I'm on DID.
Awesome.
I'm curious about your thoughts on the kind of head start Ethereum has with smart contracts and having that ecosystem already built out. Chia can compete or coexist with them in the marketplace.
So my opinion on the matter is that I believe the tech is good. Without bluster, I think that what we're building is great. The difficulty is that there is so much around Ethereum already. It does already exist, like you say, and we need to sort of convince people all these problems that they have with Ethereum, we can make them go away. And because I'm still in contact with lots of Ethereum guys, and it's always the same complaints. You know, the tech stack is lots of third-party stuff. Everyone's having to use truffle and this and that, and the test environments aren't necessarily like the real environments, and there's a lot of headache and pain that comes with the Ethereum development. So my belief is that we can win people over by convincing them that we can make those headaches go away. That's my opinion on the matter.
Very cool.
Any other questions from anybody?
How's the mainnet launch schedule looking?
I'm not sure what the official position is, but it's coming along. It's Yeah, I don't think I'm authorized. I don't know if the information that I have is like authorized for public release, so I'm careful not to run my mouth. But it's coming along. It's looking pretty nice. We're all happy. It'll be there when it's ready. If you want a better answer, you might be better asking Keybase. Sorry, that's outside of my remit.
Yeah, I think the consensus in Keybase was that they're expecting mainnet to be launched at the end of this year. That's what I remember seeing Hoffman saying.
Yeah, that's a good answer. Thank you.
So how could we get involved and get interested in Chia as getting started in it right now, just as non-developers, like working in your.
Oh, so if you want to get involved, we have a testnet that is active and live now, and we have software that you can install to participate. So our equivalent to mining is farming, and we have that system in setup. We have a blockchain that is live and real with true Nakamoto consensus, and you can run that. And you can check out chia.net and install our software. It's all open source. And you can join in, and the plots that you plot on testnet, that is like a commitment to space. So our whole thing is that instead of using GPU power, you use hard drive space. So the commitments to hard drive space that you make now, or like you make during testnet, they will be applicable as soon as we roll over to mainnet. So you can get involved now, even if you don't want to do smart contract programming.
I would say to put farming in a good light. My experience with trying to join the testnet competition for Oasis Labs was much more difficult than joining the testnet and farming on Chia. So I don't know if that makes anyone like more interested in wanting to farm on Chia, but the experience that I had, which was back in, I think, February was when I started. It was very easy and simple relative to trying to mine on other test nets.
It's a process that we've deliberately tried to make user-friendly and streamlined. And if you do encounter any problems, as I said, support and questions are answered all the time on our Keybase. So if you're even a little bit interested, I would say check out the Keybase. Is everyone happy with that?
Yeah, thanks for the presentation. It was really interesting.
All right. Thank you for having me. Thank you for the interest. I'll send the PowerPoint and some other resources through so that can go out to your mailing list. But if that's it, thanks and goodbye.
Sounds great. Have an awesome afternoon.
Thank you.
Thanks, Matt.